Hello Internet, this is JF and this is Introduction to Programming in ATS. Unexpectedly, this is a good place to stop the previous video, because from here on through the end of the chapter, it's a little bit confusing, not because it's not clear, but because it's stuff that's so obvious that you kind of start trying to parse meaning that isn't there. So I'm going to summarize a lot of this rather than just reading it outright. So for example, this entire section, Static Semantics, it's all like the entire section is displayed on the left side of the screen. I'm going to summarize that as ATS is a programming language, and it has a type system. There you go. Then we get to primitive types. What it's saying here is, okay, these are the primitive types of ATS. Like primitive as an opposed to like data types or view types or proof types, possibly like sorts or higher order types. Or functional types, and also even refined types. So if you have a val x equals 42, this can be an int 42. It could also just be an int. So the difference between the primitive and the refined type is that ATS will actually sort of do a little bit of casting here. So a literal, if you use this literal where an int is expected, then it'll be treated as an int. If you use it where an int of int is expected, so this refined type, then that'll be accepted. Beyond those kind of casting, there isn't a lot, actually, unless you add it yourself. So for example, like casting between like float and int, or int and unsigned int, like that doesn't happen the same way it does in C. Speaking of C, though, these are the same types in C. So if you have a char, if you have an int, if you have a size t, when you compile to C, you use the same types. So your understanding of an architecture from C, you can just translate that directly to ATS. It's the same. The bit widths are the same. The numerical properties are the same. And tuples. That's another one that's easy to summarize. So ATS has tuples. Oh, and those tuples, you can see right here that you index into them by dot notation with a number starting at 0. So it's not like an array like this. It's like this. So dot 0 is the first one, dot 1, dot 2. And of course you can pattern match. Like this is, we're creating a tuple right here. Creating a tuple by pulling out individual members of this tuple right here, and then we pattern match on them here. So that all works fine. And there's really nothing to say about it except one other thing. Normal tuples like this, like unadorned tuples, are the same as tuples with @ signs, which is to say they're not box tuples. They're just structs. If you have single quotes here, though, they become pointers to structs, and they're located on the heap, which means you need a GC if you deal with these pretty much. All right, and then also record types. ATS has records, and records are tuples, and you can do some partial pattern matching with like this ellipsis syntax. If you want to pattern match just part of a record, you can do that. But normally you can just use dot notation again, and instead of using dot 0, dot 1, you just use dot whatever the name is of the record, of the element of the record. All right, and conditional expressions. ATS has conditional expressions. Yeah. And it works exactly how you'd expect. Like there's nothing here that surprises you. And ATS has sequence expressions. This one is, again, a little bit more interesting. So let's say there are many parts of the syntax where you just have an expression. So like if expression, then expression, else expression. And you're like, okay, well, does this mean that an if can only have like one thing here, and then like 1 equals 2 here, and then a printf here, or like set a flag, but like, okay, you can't have like multiple statements? They can totally have multiple statements, because expression is enough to have multiple statements, because you can build expressions. So with sequence expressions. So right over there, print h, print e, print l, print l, print o. The thing about sequence expressions is that all these parts before the semicolon have to evaluate the void. If they don't evaluate the void, then it's a compile time error. Like the semicolon means the previous thing is void and it's okay. The final thing, though, that can be any type. So even though here it's void and the whole value of the sequence expression is void, this could be like a number, and it would be print hell, and then the number is the value of the expression. Again, instead of parentheses, you can use begin and end. And instead of a sequence expression, like you don't have to use sequence expressions at all. You can just use let expressions everywhere, or even where expressions everywhere. So like a where expression like this. That gives you sort of declaration space where you can have, val x, or var, or fun. And then like anything that you can do at the top level, pretty much you can do here. You can define functions and so on, but you can't have just random expressions. So you can't just say, print hello. You need to make that a val declaration. And that's the same with the first part of a let expression. And the thing there is not so much, the first part of a let expression is just like a where. But also there's a second part of a let expression, which is just like a sequence expression. So these all have to be void. And because I have a semicolon there, actually I'm not sure if the semicolon at the end means it has to be void, or if this could actually be like anything else. Let's test that real quick. Come on. Let's say okay. So you have a sequence expression. Test 1, test 2, and then we're going to call test with, let's say, test x, where val x equals the sequence expression. And just so it looks a little bit neater, so it doesn't look like a tuple, or it wouldn't be ambiguous, but I don't want to have a sequence expression like this. That's kind of silly. All right, so we're testing x, and x is the result of the sequence expression. So I'm going to end it with 100. So that should work. It doesn't work because there's a parsing error in line 22. Right here. Oh, fun. This is a val, not a function. All right, got an int 100. That's right. Now let's add a semicolon. Got an int 100. Okay, so the language doesn't punish you for having unnecessary semicolons at the end. Still, your last expression, whatever it is, even if it has a semicolon following it, it can be of whatever type. But these ones definitely have to be void. And again, we can test that just by doing it at 50. Now it's an error. The needed term is void type, and the actual term is a refined int type that happens to be equal to 50. It statically knows that that's 50. Okay. Stop recording. Okay. And also ATS has comments. So it actually has exactly the comments that you would expect from the source languages. So C++ comments behave like C++ comments. ML comments behave like ML comments, so they're nestable. And C comments behave like C comments, so they're not nestable. As this part right here. So C would parse this as a comment from here to here, and everything else is a syntax error. And then you have rest of file comments, which is if you have 4 slashes anywhere, well, so you just have 4 slashes like this, then the entire rest of the program is a comment and it's not seen. It's an easy way to just blog off parts of your program in order to test previous parts. It's also useful for documentation potentially. That's how some languages use it, like Perl and Ruby. All right, that is the end of the chapter. The next chapter is functions, and we're going to take that one separately.